Alright, so here we are again, another question. This time around, take a few seconds before I begin. I think I got everything I need. Yeah, we'll just click that button there, and I think we're ready to go. So just pop out the chat. I think I got everything I need. Yeah, that's fine. Okay, pop out the chat. Alright, so hello and welcome. Here we are. Number of enclaves. Let me show that here. Yeah, we're given an m by n matrix, binary matrix grid where 0 represents a C cell and 1 represents a land cell. A move consists of walking from one land cell to another adjacent 4-directionally land cell or walking off the boundary of the grid. Return the number of land cells in the grid for which we cannot walk off the boundary of the grid in any number of moves. Okay. So here we can walk off, here we can't. Oh, that's interesting. So yeah, a very straightforward thing I think is just to do a flood fill, and you also want to check and see if there are multiple ways we could do this. Simplest thing I can think of is I definitely want to figure out which sort of quote-unquote islands you have by using a flood fill. That's a very straightforward way of doing it, and I can explain that when I get there. But I also want to know the size of those islands that are bordering the edge, more or less. Those ones, you can walk off the boundary, you don't count those ones. The ones that you cannot walk off the boundary, those are the islands that I want. So the question is, now, yeah, there are multiple ways of doing this. So one way of doing this is, instead of using a flood fill, you can use a disjoint set data structure to figure out which islands you have. And then those islands will basically be grouped into, like, each island will basically be assigned its own integer, as well as the size. And then you can just check to see when you're merging things, you can just have an extra kind of property that lets you know whether or not that particular island goes off out of bounds or not, or touches the boundary or not. Alternatively, you could do a flood fill from each, is actually probably a better way of doing it. Flood fill from each of the boundary values first, and just set all those values to 0, and then the other flood fill will then instead of setting it to 0, it will increment I like that. You don't even need to flood fill that, actually. Yeah, I think that's actually better. I like that more. Okay, we'll do it like the following. So we'll do a flood fill. And I'll explain what that's going to look like shortly. We'll say if not r greater than equal to 0 and r is less than c greater than equal to 0. This is just an inbounds check. Also, each direction, I'll explain that shortly. So if it's not in bounds, we just return. Otherwise, we're going to set grid of RC to 0, and we're going to flood fill each direction. There's a nifty thing you can do, which is int drdc, which we're going to start off going to the right, which is going to be increment the column by 1 and the row by 0. And then at each interval, we're going to update. I think it's first you swap drdc, and then you negate. So if you had going to the right, now you're going to go down. The way that works is the row, the column becomes 1 0. So row down, column 0, which means you're going to multiply the second value by -1. Yeah, that'll give you clockwise. So you're going to go 0 1 to 1 0, swap, and then negate the second one. Then from 1 0, swap, 0 1, and negate. Right, and then again swap and negate the 0, which gives you -1 0, and then swap again and negate. That gives you the 4 different directions. Okay, and that you could figure that out using a cross product to straighten that out. So we'll come back to that in a moment, but we're going to do each direction. We're going to say constant new row, it's going to be row plus dr. A new column is column plus dc. We're going to say f of new row, new column, and f. And I think that's all I'm going to do. This is very straightforward because the inbounds check is here. Always set this to 0. This is going to flood fill strictly from the, there's one more thing. If not inbounds, or grid of RC is already 0. So it's got to be inbounds. It's got to be inbounds, and grid of RC is not 0, right? All of those things are true. If it's not that, then we return. I think that's all I need. It's very straightforward. There's one more thing here, which is just a count or direction. Going through all 4 directions. This could be just some index too, it doesn't really matter, or direction or something. Yeah, okay. So that's a straightforward flood fill. So you can do the first row and the second row. Int I is 0, I is less than n. Do 2 loops. So this is going to be the first row and the second row, but each column of those rows, right? From 0 to n is the number of column, or the number of rows is m, number of columns is n. Number of columns is the number size of the rows, yeah. So we're going to flood fill it's going to be row 0 and column I, and the last row at -1 in column I, and the same thing over here. Similar thing over here. Yeah, okay. This is going to be now each row and with the first column. So each row, first column, and each row, last column, right? So now that'll set everything that can go out of bounds to 0, and then we're going to run a second. We don't actually need to run a flood fill this time around. We can just run an accumulation routine. It looks like the following. And we're just going to say, let's do it row and column this time explicitly. Yeah, and this could just be everything. It doesn't matter because I set everything to 0 already, so that should do it. I think that's it. See if there's anything else I need here. Okay, I think that's it. I want to just go for it. You know, what are my bounds? Okay. Yeah. I'm just gonna go for it. Just freaking. Here we go. Oh, got it. Very good. Hail victory. All right, let me submit it a few more times, and then we'll go to the next one. Yeah, that one's pretty straightforward. Not too bad. Also, yeah, my headlamp here. This is just so I can see my keyboard. Hopefully, it's not too blinding for the camera. So yeah, if you like the 90% is pretty good. If you like the stream, don't forget to give a like on the video and also subscribe. And we'll submit one more time. 1, 2, 3, 4, 5, and then we'll stop streaming. Just restart the stream with another question. So not too bad. Not too bad. Thank you.